Related to the cost of solar power in Canada, the average installation cost of solar power is $3.07 per watt, or $23,000 for a 7.5 kilowatt system. Specific price per province is shown in chart on the right. For the calculation, you'll need to determine how much energy you use over the course of a year in units of kilowatt hour by adding up the amount shown on your power hydro bill. The next thing you need to know is how much energy your panel can produce based on the area that you live in. This number can then be multiplied by the estimated cost per watt quoted in the pricing table to get your final price.
The solar panel, also called photovoltaic cells, are made up of 3 layers of crystalline silicon. One is the P layer, which includes some boron in the silicon atom structure. This causes the layer to have an overall positive charge because of the fewer electrons in that layer. The next layer is the junction layer, where most of the reaction actually happens. After that is the N layer, which includes phosphorus to add electrons and thereby giving that layer an overall negative charge. The solar panel generates a current when photons collide with electrons in the junction layer, knocking them free from the silicon atoms. The electrons flow to the N layer, and the holes, or positive charges, shift down to the P layer. This creates a voltage difference within the silicon layers. When wires are connected to the N and P layers, a current is then produced as a result of this voltage difference. It can then be stored in a battery or other means of electric energy storage. Commercial solar panels have between 10 and 30% efficiency. One reason for this is due to electrons falling back into their holes, or positive charges, instead of traveling into the N layer of silicon to create a current. Another reason for this low efficiency is because sometimes light is reflected off the solar panel rather than being absorbed into the silicon.
Main challenges associated with making solar energy affordable. The first is the inconsistent solar light availability, meaning that not all regions across the Earth get a consistent amount of light year-round. This is low material purity, which leads to low efficiency of panels, allowing them to only collect about 10 to 20% of sunlight. Additionally, this energy must be stored securely. This factor, in addition to the fact that the panels need to be well maintained and clean at all times to ensure that they are capturing the most amount of sun, leads to high installation as well as operating costs. Finally, the biggest challenge is finding the funds to support further development and research to improve the solar panel and their efficiency. So who is involved in improving the efficiency of solar panels and making them more affordable? Mechanical engineers are involved in the research and development of devices used to capture and transfer solar electricity, as well as are responsible for the machinery which manufactures solar photovoltaic equipment. Materials engineers experiment with and perfect materials such as metals, plastics, glass, and semiconductors used in solar energy systems. Electrical engineers design and develop the electric components of solar systems, such as electric circuitry, inverters, wiring systems, and more. Industrial engineers research sites, energy usage, and system capabilities of solar energy systems in order to coordinate their implementations with contractors. Chemical engineers focus on developing solar panels from the semiconducting organic materials. As for non-engineering professionals, chemists research on a molecular and atomic level the structure of organic materials used to manufacture the solar panels. Physicists research on a molecular and atomic level structure of organic materials used to help improve the performance of solar cells. Finally, energy brokers work as intermediaries between producers and consumers. Together, these professionals, both engineers and non-engineers, are using different fields and working together to make solar energy affordable.
SolarStar is the largest silicon solar farm and it is located in Rosamond, California. The site area is 13 square kilometers and has the annual net output of 1,685 gigawatt hour, and 1 gigawatt hour is roughly 1.3 million horses, which represents enough power to power 255,000 homes. Its use is costly, but it is high-efficiency crystalline silicon modules from which one can extract electricity from the solar energy makes SolarStar an interesting option. Indeed, it uses less modules than other solar farms. For instance, SolarStar uses only 1.7 million modules compared to the 3.8 million used by the Antelope Valley Solar Ranch, a solar photovoltaic plant nearby SolarStar. Furthermore, its cleaning system is fully automated, which saves time and reduces costs because it barely requires manpower to do the maintenance.
The case study is about the Longyang Dam Solar Park. It is located in Qinghai, China, on the Tibetan Plateau with the altitude of 2,460 meters with 24 square kilometers. Project installation is costly of 1.12 billion Canadian dollars. The profit from the electricity revenue is limited, but the revenue from subsidy, related industry, and brand influence is significant for the company's overall profit.